Good evening, everyone. So, welcome to Science Academy. So, this is the second part of this radioactive lecture. So, previously we have discussed about what is radioactivity and the how the radioactive elements decay, what is the relation between them and the decay curve, etc. Now we'll find out the value of disintegration constant. Okay, so previously what we have mentioned that n equals to n0 e to the power minus lambda t. So we'll find out the value of t, this equals to 1 by lambda. Okay, so if we put this value 1 by lambda equals to t in the equation, then we can write n equals to n0 e to the power minus lambda divided by lambda, because lambda t, and here I have put t equals to 1 by lambda. So this becomes n equals to n0 by e. That means the number of undecayed particle is equals to 1 by e times the number of original number of particles. So 1 by e has the value 0.368 times n0. That means n equals to 0.368 times n0 when the time is equals to 1 by decay constant. So we can write that n equals to n0 by e. That means we can say that this is 36.8% of n0. So the radioactive decay constant is defined as the reciprocal of the time interval during which the number of active nuclei reduces to 1 by e times of its initial value. So we can define the decay constant lambda as a reciprocal of time, that is 1 by t. So this is the time interval where the number of undecayed nuclei is equal to 1 by e times the number of nuclei present initially. Okay, that means 1 by e means 0.368. So minus dn by dt equals to lambda n. We can find the value of lambda. This equals to minus dn by dt divided by lambda divided by n. This is another formula for decay constant. So generally decay constant depends upon only the nature of radioactive substance, nothing else. So it only depends upon the kind or the kind of radioactive substance we are taking. Now we'll study about the half life. So the name or the word suggests that half life, that means the total lifetime, half of the total lifetime. So half lifetime of a radioactive substance, this is defined as the time interval during which the quantity of radioactive substance is reduced to one half of its original value. That means this is the time, half life means this is the time interval where the radioactive substance or the quantity of radioactive substance that reduces to one half of its original value. Okay, so any kind of nuclei or any kind of radioactive substance, when it takes some particular time to decay to becomes one half of its initial value, then this is called half life. So it is generally denoted by t half. So from the relation, that is n equals to n0 e to the power minus lambda t, will generally put this kind of conditions that at t equals to 0 n equals to n0. Whenever t equals to t half, then we can say that n equals to n0 by 2, because this is the half of the original value. Clear? So at a half lifetime of a sample, we can write that n equals to n0 by 2. Okay, because just use this formula. Put n equals to n0 by 2 and n0 equals to n0 and e to the power minus lambda t. In place of t, we'll put just t half, and t half refers to the half life of the substance. So do the usual calculations, n0 will be cancelled and we'll get half equals to e to the power minus lambda t half, and from this we'll get lambda t half, this equals to log e2, and just use the formula, you put the value of log e2, that is 2.302 log base 10 2. Okay, so this is the relation between log e, and that is log base e, and log base 10. So usually after doing some calculation, we'll get that this value is equals to 0.693, that is lambda t half equals to 0.693. That means the value of t half equals to 0.693 divided by lambda. That means t half is equals to 0.693 divided by the decay constant. So we can find the relation that T half is inversely proportional to the decay constant. Okay, so whenever decay constant is larger, that means the half life of the substance is very very small, because this is used general